breaks and stops. The worst code is code that silently corrupts your data, although you don't know it. And this might be such a case where this could creep into your code. So this is also why patterns are important, because you just see this somewhere and just automatically adopt it without knowing what it does exactly. What it does, though, is it checks against this. If the string is 0, which it might be not if this happens, this might be 1, or this might be -1. This is going to check, this is going to guard against an entirely different case, which might be related to checking against null, but sometimes this is just a nonsense case if null happens to be -1. If null happens to be -1, like in the system internally, this case would do nothing at all. It might check you against some random value, but null cases might still continue after this and give you a lot of damage afterwards. So doing this is the actual recommended way to check against this. And yeah, so this I don't really recommend. It might crash randomly, it might give you a lot of headaches trying to debug things, and the worst thing you can do is spending too much time debugging. Because when you debug your code, you're often tempted to just add something and cross some sections out, and then your code becomes a pretty big patchwork of ideas, all from different points in time. So one patch comes from Monday morning, one patch comes from Monday evening, like one patch from Monday very late in the evening when you are so tired that you don't know what you're doing, and then you come back later on and just build on top of this. And of course, every time you do a patch, you make your code more complex. And if you make your code more complex, well, it becomes harder to understand, harder to debug, and things are just keep getting more complicated. And therefore, to avoid these things, sticking to the patterns, and if you see that something doesn't work, cross out the pattern, maybe delete the entire function and write it again. Like the reason why so many people are afraid of rewriting their functions is because writing code is hard. And writing code is harder if you don't know your patterns. If you know patterns, you can just copy them in. You can just type these out of your memory, and then you just have to write 2 patterns instead of 1, 2, 3, 4, and so on lines. If you think in patterns, well, I take that pattern out, I take that pattern in. If you think in lines and characters, then you are tempted to do all of these patches in here. And when you do patches, you're going to shoot yourself in the foot later on, because you keep building up some kind of mess here, and you are going to forget what you were doing. So patterns are helping you keep things straight. And in case of these errors that are so hard to get, sticking to a few well-established patterns is often better than coming up with something that just crosses your mind. Oh, let's do an if statement here, okay, I've seen that person do it, so I'm just going to throw in this, it's gonna work. But if you don't reason about what you're actually writing, if you don't know what you're writing, okay, I guess that's going to work, then you might end up with cases that you never intended, and you're not going to notice because you don't know what this does. So knowing about patterns and what they do, and then only having like 20 or 30 patterns that you know, instead of having to rewrite everything from scratch, then patterns are mostly the way to go. Okay, so this was a pretty long answer to your question, of course, but the thing I want to establish is think in blocks of code. Always keep them similar. If other people look at your code, they might recognize these patterns again, and also this makes it easier for them to notice what's going on. And this is really important. You don't write code for the machines only, you also write code for the people to read it again. Okay, so let's get back to the guard patterns, because this is only one guard pattern. There's also another guard pattern, and this is basically what I'm aiming towards now. Because the purpose of a guard pattern, maybe let's switch the color, so that you might be able to recognize this a bit better. So another pattern is this is also a guard pattern. Who recognizes this? Who knows what this does? We have already seen this a few minutes back. this was the part of the atoy function that skipped the white spaces. And this is quite related to this. And why is that? Well, let's say you have your atoy function that has spaces in front, and then you plus 42. What this did is it took this and turned it into that. What this one did is it took str being null or str not being null. This is what was before. This is also what was before. And afterwards, str was always not null. And afterwards, the space was always removed. Sometimes there wasn't any space. And afterwards, there was definitely no space. So what guard patterns do is they take one state, multiple options maybe, and somehow give you a simplified version. Here str might be null, which is dangerous. Here it is never null, because I've guaranteed with this pattern that it's never going to be null. And now in this code we have a simplified version that allows us to, well, just dereference this string without having to worry about the system crashing. And here we can now just access the first character and can be sure that it's not going to be spaces. We don't have to worry about spaces anymore, just like we don't have to worry about str being null from this point onward. And this is what guard patterns do, and there are quite a bunch of them. Maybe too much to talk about all of them here, but it's important that you get the idea. Initialization patterns were responsible for putting meaningful values into your variables, and guard patterns are there to protect you from values that are already initialized, like this variable, but that might contain values that don't make sense or shouldn't make sense to you, or that should be removed. Like spaces should be removed, so we don't have spaces here. And this is what guard patterns do. And there's more than that, but I think somebody should write a book about these, because they are really a bunch to talk about. Okay. Do guard patterns make sense to you? Yeah.
Quick question, should we put the guard pattern in every function we write, or just in the function where we get outside data?
That depends on the context. So, what's outside data? For example, outside data might be, in this case, it was strn. In this case, this ABC value is outside data, because it comes from the outside but gets passed inside of this str. So this goes in here, and therefore it's data from the outside. But let's say somewhere in your code you wrote str equals some kind of value, your function f, which is another function that somebody else wrote, which sits at a completely different point. Is this also data coming from the outside, or is it data coming from the inside? Difficult question, right? Because the code itself is sitting outside, but you're calling it actually inside of this function call. Like, it's actually being produced inside of this, but technically it's coming from f, which is still outside of our scope here. So the answer to your question is put guard patterns whenever you get some data that could be two or more different cases, but you want only one. If you want something that's not null, but it could be null because you don't know what this is going to output, then put a guard pattern in between, just to be sure. If you just assume things, as long as this function doesn't tell you in its documentation, like the man pages or something, if it doesn't tell you that it will never return null, always assume that it could. And if it could, and you don't want it to, put a guard pattern in between. That's important. Okay, any further questions? Yeah.
So in clean code it is easy to read. Would you always initialize all the variables first and then put in the guard patterns?
Yeah. So it also, again, it depends. Some variables should, like most variables should be initialized first. Because sometimes you just say, okay, let's clear the board a bit. So this is actually a very important part. So when should you initialize your variables? Let's say you have a function, as always, and you have some kind of pattern sitting in here. And in this pattern you say I equals 0, and here int I. And now something doesn't work, and you decide to delete a part of your code. Let's say you just say, okay, I'm going to remove this part that doesn't work. But then you say I++ or printf I. What would happen? Because you deleted something without looking at it further, without looking at the implications of deleting it, somehow you manage to kill the initialization of I equals 0. If you put it at the top, as always, the chances of randomly deleting a piece of code and thereby killing the initialization, the chances of that are quite low. Actually, you really have to put a lot of effort in to reset this variable or to kill this declaration if it always sits at the top, separated from the rest in between. So yes, the short answer is always initialize from the beginning, always initialize at the top, and then just use the variables afterwards. But sometimes you can't avoid it. Sometimes you need to store the length of a string, maybe, that you got as a parameter. So you get a char star str, and you want I to equal strlen of s, tr, and maybe at some other point you need to store a different value and then repeat an entire process. This is not going to happen often, but sometimes a variable's value has to be updated, and in some cases, in some very rare cases, doing this twice doesn't make any sense. So doing it in line, maybe inside of another pattern, might be a good option. And in these cases, you need to be very, very careful what you're doing, because the chances of you just deleting a pattern without, well, deleting the variable itself or initializing it with a correct value might lead to, again, uninitialized